I'm going to show you how I test my project 4. So project 4 is an extension of project 3. And in this one, I have applied Paxos and implemented Paxos into this project. So this will make this distributed system fault tolerance. And before we get started, I just want to let you know, although Paxos does not guarantee data consistency, I have found a way to achieve this goal. So in this system, the client, when he or she tries to connect to the server, and the client can choose to connect to any of or all of the current available servers. But the client does not know what happens on the server, and no matter if any of the servers is down or if there are new servers joining, let alone the newly joined server will also serve as a replica and additional bandwidth to empower the service. All available servers provide a stable service for a client. That is to say, from the perspective of a client, all a client can get is consistent and a stable service. Okay, without further ado, let's just get started. Based on the information provided in the TA session, I'm going to first run 5 servers running and put to one server and get from this server to see if the operation whether or not it's successful. So let's try. This is the coordinator which has all the information and uh, let's start all these 5 servers. This is the first one, the second one, third one, fourth one, and the fifth one. And now let's connect to the servers. You can see this client tries to connect to the server, and currently running server ports are these 5. And enter the port number you want to connect to or type in to proceed with all available servers. So we're going to test the scenario 1 by running 5 servers and connect to one and operate on one. Okay, let's try to connect to 1774. You see, it works. And please type your request, and let's try put both 350. And a success. Let's try to get both. Succeed. And at this point, you can see, although this client tries to connect to 5 servers at the first point, that is true. But during this time, the first server is down. You can see the server on port 1773 stops running. This is the requirement I met in the project. I configured to let some certain server to down automatically and restart later. So during this time, although the first server is down, but the client does not feel anything, and you can see all this server is all these server runs pretty well, and the client does not know anything. But what if you can say at this point it restarts running? Let's just try to, for example, put Sony 3000. You can see it works. And get Sony, it gets 3000 back. And at this point, how about this? Let's try to wait for this server. It stops again, and let's try another client trying to connect to the server. Let's see what happens. And before that, I just want to let you know, you can see during the pre-population part, there are some warning messages called failed to do put and retrying. This is another way that I try to simulate that one server or the acceptor will be down during the process. But according to the Paxos, if the proposer cannot get enough, sufficient, the majority of responses from the acceptors, it will just retry. And by increasing the proposer ID, but piggybacked the same content to try again, and in this logic, I make my system to continue trying until the operation is successful. And you can see at this time, the server on port 1773 stops running. Let's try to another client to connect to. Yeah, you can see at this point, the client tries to connect is only 4 servers. So so this server does not exist. That currently does not provide service for this client. But as I mentioned in my testing screenshot PDF, as long as this server resumes operation, it will join the server list to provide service for this client. So this means the client, although it first connects to the rest of 4 servers, but when this server resumes operation, it will join this service provider list, but without notifying the client. This is for the consideration of client that does not need to know what happens on the server end. It just needs to get a consistent and a stable service. Let's try this one. How about put dog? Uh, okay. Let's try this one. 1775. Okay. Put dog dasher. You can see successfully put dog dasher. And also for this one, it still runs for this client. Okay, this is enough. Let's try to test the scenario 2. And I'm going to put from one client. This server connects to the, remember, 1774. And this client connects to 1775. So I'm going to put from, how about I put phone 899. And I'm going to get from this server, this client, to see if they enjoy the same data, if I achieved the data consistency. So get phone, yeah, get phone 899. So this means my implementation works. And let's try to move on. Only 3 servers are alive, so I'm going to queue this one. Queue this one, queue this one. So at this point, there are only 3 servers alive. Let's try to put pig big. Okay, let's get pig. Okay, works. Get pig works. Okay, let's delete pig. Successfully deleted. Get pig. Okay, does not exist. This is our expectation. And you can see at this time the server on port 1773 stops running. This is something that I mentioned before. It's configured to stop and restart running. And as long as it resumes operation, it will provide the service again. So let's continue to killing all the other servers. Let's try to killing the 1776. So at this point, there are just this one and this one. It still stops running. So that means actually there is just the one server running. So let's try get, okay. The first server restarts running. So let's just put something. How about put water 100? Okay, works. Get water 100 and get water 100 and delete water. Okay, delete water, get water. Yeah, does not exist. Okay, so this means although there's just a one server running, it still provides service for the client. And let's just see, since there's actually one server that is I manually killed, let's just kill this one. So this means at this point, there's just a one server running on 1773. Let's try another one. How about put what? Put doggy, and get doggy. Okay, it works. How about get apple? This is for the pre-population key, and get cheap back, and then get apple. It gets cheap back. How about, since this one is configured to fail, to stop, let's try when this, what happens when it's configured to fail, and what happens to client. So, and oh, it stops running. So let's try get apple. You can see at this point, no server available. That means the server has to, since this client has already connected to the server, so the server cannot force the client to exit. It just provides the information for the client, no server available. So the client maybe try later. And at this point, it will try later until this server resumes running, and it will still get the service back. But at this point, if another client try to connect to the server, let's try what happens. You can see no running server available. Please try again later. So this is a pretty user-friendly information. And let's wait. If it resumes running, let's just wait and see if there's something beautiful happens. Oh, it restarts running. Let's connect. Yes, there's just a one server that is open for 1773. So since there's a one, I just type in because I want to proceed with all available. You can see it still works. And since moments ago, there's the information no server available, let's just try get Apple. You see, it resumes running. It resumes the operation. And for this, delete, Apple successfully deleted. And get Apple does not exist for this newly client. Get Apple. Okay, and now we just resume all the servers that we killed before. Resume 1774, 1775, 1776, 1777. I just resumed all of the servers. Let's just try. So put rice brown. Okay, successfully put. Get rice, get brown. Get rice, get brown. Delete rice, successfully deleted. Get rice does not exist. Get rice does not exist. Okay, so you can see all these scenarios works, and I also introduced to you my highlight. I just want to know for this part it has the information for the administrator, for the engineer, because the engineers need to know what happens in order to improve the performance, improve the algorithm, improve the code. But for the client, they don't need to know anything. They just need to get the stable service, and this is something that we have achieved. Okay, that's all. Thank you very much. I hope you enjoy testing my program. Bye.